moles of component. So first of all, you see that is number of moles is equal to what? Given mass upon molar mass. Given mass is there 8.5 grams. So I wrote here 8.5 gram divided by 17. So it is coming 0.5 mole. Now what we need to do here, you see, active mass is equal to, I told you, moles of component divided by volume in liter. So here what is moles upon volume in liter? Moles you got 0.5. Volume 4, if you are dividing, this is you are getting 0.125 moles. So you can text Janab, nothing is coming. What you are talking, no sound is coming. This is the question I wrote here. Okay, you need to solve this. They have given what? That is, what is the active mass of 1 liter of the nitrogen gas at NTP? Right. This is what is something the question. Now, when you are talking about what is the active mass of 1 liter of nitrogen gas, right? 1 liter of nitrogen gas they are talking. Okay. So at NTP, when you are going at NTP, what is their volume of 1 mole, you can write that is volume of 1 mole of gas is equal to 22.4 liter. Okay, 22.4 liter. So also you can write what we can write 22 point, okay, 4 liter is equal to 1 mole. Okay, 1 mole. So 1 liter. So 1 liter is equal to 1 liter is equal to how many mole? 1 upon 22.4 mole. Okay. Since it is per liter, so how much value you are going to get? Here is 0.44, no, 0.044. This is going to be, that is moles per liter, because that is already they have given per liter. So this is our answer. This is the problem number 2. Now what we are going to do, we are going to solve some more problem on active mass only. Let us try to solve. Okay, the question here I am writing. So question they are saying, calculate the calculate the active mass of calculate the active mass of 5.6 liter. Calculate the active mass of 5.6 liter of O2 at STP. Okay, right now this is the question they are asking. Okay, so how can we solve? That is option also given, 5.6 upon 22.4. Okay, then they are saying 8 upon 5.6, and again they have given 32 upon 5.6 and 0.25 upon 5.6. This is there. So this is A, this is B, this is going to be C, and this is going to be D. Now we are going to solve it out. Okay, solution we are making. So how can you solve, Janab? Okay, so when you are talking about this, so 5.6 liter is there at STP. So if you see at STP, what we can write at STP, volume of at STP volume of 1 mole of gas, volume of 1 mole of gas is equal to, okay, at STP volume of 1 mole of gas is equal to 22.4 liter. Yes, or you can write that is 22.4 liter is equal to how many moles? 1 mole. Okay, 1 mole. Now what we are having, that is, therefore 1 liter is equal to how many mole? So that is 1 upon 22.4 mole. Okay, 4 moles. Now they are saying therefore 5.6 liter is equal to how much? 1 upon 22.4 into 5.6 moles. So how much answer is coming? 5.6 upon 22.4. So it will be what? Mole per liter. So this is the active mass. Which one, which number option is matching here? You can see 5.6 upon 22.4. So correct. Here is the option number A itself is our correct answer, right? So likewise, you can solve the many of the problem. Okay. The similar problem also you can solve. Here I am giving you some more problem here. Okay. Let us try to solve one more problem. Next problem. Problem number 2. So here what is the problem? Calculate the, they are saying calculate the active mass. They are saying calculate the active mass in bracket, what they are saying, molar concentration. Active mass in bracket molar concentration. Active mass in bracket molar concentration. Okay, of 64 gram of SO2. Okay, in a 4 liter, in a 4 liter, okay, flask. Option they have given, what are there? 2 mole per liter. They have active mass is capital M, mole per liter. 1 capital M. Okay. Here you, if you are saying C, that is 5 capital M, and D 0.25 capital M. So let us try to find out the answers there. How can you be able to understand? So you know very well that is active mass. How to calculate? Active mass is equal to moles of component. Moles of component. This is what? Moles of component divided by volume of solution in liter. Volume of solution in liter. Volume of solution in liter. So moles of component. So we don't know the how many mole, because here what they have given, gram mass they were given, they have given. So moles of SO2, if you are writing moles of SO2. So what is the formula? Moles of SO2. If you are calculating moles of SO2, so it is coming what? Given mass upon molar mass. Okay, given mass upon what? It is going to be what? Molar mass. Given mass upon molar mass. So given mass is how many? 64. Molar mass, what is there? S is there, plus 2 into O is there. So that is 64 upon what? 32 plus 32. It is going 64 upon 64. That is, it is going to be 1 mole, right? So moles of component, how many are there? 1. Volume of solution in liter, how many liters are there? They are saying calculate the active mass of, okay, volume of, no, per mole, that is 1 liter is there. So how much will be there, student? How much is the answer will be? 1 capital M. So correct answer will be here, you know, in 4 liter, sorry, in 4 liter they have given, not 1. So here 4 is there. So you calculate, sorry. So if you are calculating this 1 upon 4, so it is going to be what? 20, you know, 0. No, 25 25 molar, you know, capital M, or 0.25 moles per liter. So this will be our answer, Jana. This is our answer, right? So okay, now what we are going to understand here, the equilibrium constant already I described to you yesterday. Okay, so let us try to move out the equilibrium constant. Once more I am telling you, equilibrium constant for gaseous system, for gaseous system. Okay, this is what the important point, gaseous system. Okay, now they are saying in term of what they are saying, in term of partial pressure, in term of partial pressure. This is what, in term of partial pressure. So how can you be able to answer this one? How can you be able to answer in term of partial pressure, right? So when partial pressure, when partial pressure, when partial pressure of each component given, each component given, each component given, then equilibrium constant is known equilibrium constant is represented how they are represented by Kp. They are represented Kp and defined as how they are going to defined. Okay, defined as, so that is product of partial pressure of product of partial pressure of product. What is today we learn Kc. Today we are learning Kp. Product of partial pressure of product raised to power. They are saying raised to power. What power we are going? Raised to power coefficient. Raised to power coefficient with product of, they are saying with product of partial pressure of reactant. Partial pressure of reactant. Partial pressure of reactant raised to power, raised to power coefficient. That is what we are going to defining, how we are defining in the term of, we are defining in the term of what? Partial pressure Kp. So that is again, if you want to, that is when partial pressure of each component given, the equilibrium constant is represented by Kp, and they are saying and is defined as, how they are saying product of partial pressure of product raised to power coefficient with product of partial pressure of reactant raised to power coefficient. Okay, now see what is the meaning of this. A mole of A is there plus B mole of B is there. Okay, then they are giving reversibly C mole of C plus D mole of D. This is the gas, this is going to be gas, this is going to be gas, and this is going to be gas. Now what we are saying here, you see what we are doing here. They are saying that is its value is given in the term of ATM. Okay, partial pressure of each component is given ATM. This is also given ATM. So how to write that is Kp. Okay, so Kp, the formula already I wrote now. Product of partial pressure of product. Product of partial pressure of product. Product of partial pressure of what? Product, divided by what we are writing, that is product of partial pressure of reactant. Product of partial pressure of reactant. Okay, and what we will do, that is coefficient we will write as usual, reactant. So here you see product of partial pressure of product, what are there? C, that is partial pressure Pc, multiply by what? That is Pd. And what are the power are there? What is there here is, that is C, and here is D, divided by what is there? Pa. Power what will be there? A into Pb, and power will be what? That is B. So this is what the representation of, that is Kp, right? So this is our required answer. Getting my point? Okay, so this is what, that is the relation for the Kp. Now we need to solve the problem based on okay, we'll do the problem based on it tomorrow. Okay, thank you very much.